Good morning, guys. What I'm going to teach you guys how to do today is how to do the quadratic formula. So you guys have learned a couple of different things so far. You guys have learned about normal factoring, and you guys have learned about completing the square. Today, you guys are going to learn about how to use the quadratic formula to find solutions. So let's do a quick review here. When we are doing factoring, all right, with factoring, what we do is we look to see how could we factor make two factors using the last constant term and the middle b term. So our a is 1, our b is -7, and our c is 12. So what we look for is, in order to factor this, we want to find two numbers that multiply to 12, but add to -7. When I think about my factors of 12, I think of 3 and 4. And that works because if I make this negative and this negative, it multiplies to positive 12, but adds to -7. So when I go to factor this, you can use an area model. I would have x squared here, and then 12 over here. And then in my other ones, I would have -3x and -4x. And then I find the GCF, the greatest common factor of each row and each column. So here, the biggest number that goes into both x squared and -3x is x over here. And it doesn't matter if you start with a row or a column. And then over here, I would take out a -4 because it is negative right there. Because 4 can go into 4 and 12. And then over here, my biggest number that goes into both would be x. And then the biggest number that goes into -3x and positive 12 would be -3, because again, that first number is negative. And then what I do is I multiply these two together to get x minus 4 times x minus 3 equals 0. Then because each one equals 0, I can set both each individual piece here and here equal to 0. And so then you would have x minus 4 equals 0, and then x minus 3 equals 0. And then if I add 4 to both sides, I get x equals 4. And then if I add 3 over here and 3 over here, I would get x equals 3. And so my two solutions would be 4 and 3. And you guys can always go to Desmos to check that if you needed to. With my screen record, I can't switch between screens very quickly. So just remember, you can always use Desmos to check. Now, when it comes to completing the square, what we are going to do is completing the square. The first step in completing the square is to move the constant term over to the other side. So moving this 12 over here. So I would do the opposite of adding, which is subtracting, and get x squared. And I'm going to leave a little space after the 6x over here equals -12. And then what I do is then I'm going to take my b term, which is -6 divided by 2, and then square it. So that would be -3 squared equals 9. And then I add 9 to both sides. Perfect. And then I would get this over here, which is a perfect square trinomial. So that would mean that I can make this x minus 3 squared equals -3. All right, once we do that, then what we're going to do is, all right, now that we have a square root, or if we have a square on the left, we can take the square root of both sides. And you guys should notice on the right that we're going to take the square root of a negative number. So that means we're going to have to use some imaginary numbers here, which we can do. So we're going to have x minus 3 equals the square root of -3, we obviously need to simplify this. And what we're going to do is remember the square root of negative 1 represents I. So I can pull out an I and I can say x minus 3 equals I square root 3. And then all I'm going to do is to get x by itself, I'm going to add 3 to both sides. And then x equals, now I'm going to put the 3 first. Typically you want to put the put the number first, and then you want to put the imaginary part second. Now I did make a slight mistake here, and remember when we take the square root of a number, we are taking the positive and negative version of that. So I need to put a plus or minus there and a plus or minus here. And then this is going to be our x is going to equal 3 plus or minus I square root 3. All right, and that is our final answer. And again, if we have a quadratic, we're always going to have 2 solutions, right? Even if they are real or imaginary. Plus or minus I square root 3. Now, if all of those steps are a little bit too tricky for you, you guys are going to have a third way today, which is called the quadratic formula. The quadratic formula was found by mathematicians way back in the day, that if we plug it into this formula, we can get the solutions to any quadratic. So whether they have real solutions or whether they have imaginary solutions. Okay, it can be used anytime. It's one I like to use this one a lot, mainly because I know that if I use it, I'm going to get my solutions. And so this is the formula that you guys want to know. This is going to be very, very, very useful for you. You guys should try to memorize it as best you can. And so really, once you label each piece, because you're going to find A, B, C in your quadratic, then you guys can plug it into the formula and solve. It's very straightforward. So I like that. So here we go. So there's a couple different ways that you can go about doing it. So the first thing that I'm going to do here is we're going to start with example number 1, and I'm going to label what A, B, and C are. Our A is the number in front of x squared, which is 1. Our B is going to be the number in front of x, which is -5. Don't forget that negative. And then C is going to be -24. Now, you guys should notice that there is a plus or minus right here. So remember, you're always going to get 2 solutions. So the first way I'm going to show you is I'm just going to break it into 2 different parts here, and you're going to have to simplify. So I'm going to do the plus over here and then the minus over here. So this will be plus, and then this will be minus. And so I'm just going to plug it into my formula. Now it's negative b. So envision that this is a -1. So I'm going to do -1 times -5 plus the square root of -5 squared, put that in parentheses, minus 4 times 1 times -24. All divided by 2 times 1. And then you just simplify it from here. So you guys would have +5 because it's -1 times -5 plus -5 squared inside the parentheses is 25. Now, this is where you guys are going to have to do some math here. And you guys are going to have to do -4 times 1 times -24. If I can get that into Desmos here real quick, that is going to be, it's going to be positive because we're doing a negative times a negative. And it is going to be 96. And it's going to end up being a plus divided by 2 times 1, which is 2. And then if I add underneath the square root radical is what we call that. 96 plus 25 is 121. Divided by 2. Now, some people don't split up the plus or minus until this step, and that's fine too. It works the same way. And now if I were to take the square root of 121, that would be 11. So I'm going to do 5 plus 11 divided by 2. 5 plus 11 is 16 divided by 2, and that would give me 8. So one of my solutions is 8. Now, what I'm going to do just to save a little bit of room, because apparently I need more room, I'm going to move this up here, and I'm going to just change that plus to a minus. So I'm going to do 5 times the square root of 121 divided by 2. So again, this is 5 minus 11 divided by 2. And then 5 minus 11 would be negative 6 divided by 2. So my other solution would be negative 3. And those are your two solutions for this quadratic formula problem. Makes your life a lot easier, right? And so again, lots of different ways to go about it. When you're solving a quadratic, I do like the quadratic formula because it can be used at any time. All right, let's keep going through these examples. And so here, what we're going to do is, again, I'm going to label A as being 1, B as being positive 5, and then C is going to be positive 5 as well. So then what we're going to do is then we're going to plug it in. I'm going to do it just the first time once, and then I'll split it up when I get to the plus or minus just to save a little room. So again, I'm going to have negative times 5, because this time it's not negative, plus or minus the square root of 5 squared minus 4 times 1 times 5, all divided by 2 times 1. So then this would be negative 5 plus or minus the square root of 25. This time it's 4 times 1 times 5, and it's negative 4. So this would be minus 20 divided by 2, because 2 times 1 is 2. And then if I keep going, I'm going to have negative 5 plus or minus the square root of 5 divided by 2. Now this cannot be simplified anymore. We cannot simplify that radical or that square root of 5. Therefore, we would want to leave our answer just like this, right? We don't want to put it into a decimal because then that wouldn't be precise. It wouldn't be exact. Leaving it just like this is fine. And again, that's another good reason why to use the quadratic formula. All right, now moving on to a couple of examples where A is not 1. It still doesn't change too much because you can still plug it into the formula, but it is a little bit, it takes a little bit more legwork. So what we're going to do is, again, we're going to have A is equaling the number in front of x squared, which is 4. We're going to have B, which is 8. And then we're going to have C, which is negative 1. All right, and then I plug in. Again, I'm going to wait to break it apart into 2 until towards the end. So I'm going to have negative 4. And again, if you don't want to use parentheses and just call it negative 4, you can. Plus or minus the square root of b squared. So then that would be positive 8 squared minus 4 times 4 times negative 1. All divided by the square, or not square root, 2 times 4. So then we're going to have negative 4 plus or minus the square root. 8 squared is 64. And then this is negative 4 times negative 1. So essentially we're multiplying two negatives. And then 4 times 4, so that would be plus 16. 2 times 4 is 8. All right, we're going to keep going. And then 16 plus 64 would be negative 4 plus or minus the square root of 80 divided by 8. Now, again, what you want to do here, guys, is you want to simplify that radical. You don't want to leave it so that it's not simplified. So what you guys are going to do is think about what perfect squares can go into 80. So when I start thinking about this here, I kind of just start breaking it down. Okay, if I do 80 divided by 4, that's a perfect square. That would be 20. All right, I know another perfect square that is 20, and that's going to be, and if I look at 20, and if I divide that by 4, it's 5. And if I multiply those two together, I would get 16, which is also a perfect square. So I can really rewrite 80 as 16 times 5. So then here's what I'd have over here. I would have negative 4 plus or minus. Now, if you would take the square root of 16 times 5, I could go ahead and pull out the 16 and make it 4 square root 5 divided by 8. Now, If you left it here, you would probably get majority of the points on a test or a quiz. But we can actually simplify this even more. If we look here, guys, our denominator is 8. We can simplify this because 4 can go into 4 one time, and 4 can go into 8 two times, and so can this 4 right here. So we can really simplify this to -4 plus or minus the square root of 5. Oh, sorry, I messed up there. Shouldn't be -4 there because I divided it by 4. It should be 1 divided by 2. And that's your final answer. Good. All right. Moving on to example number 4. Now, again, if you get confused on where I'm at, sorry, it's kind of just flopping over here, but hopefully I can get this figured out. So again, on example 4, I would have A equals 4, B equals 11, and C equals -20. All right. And so again, just plug it into the formula. I would have -11 plus or minus the square root of 11 squared minus 4 times -20 divided by 2 times 4. I would have -11 plus or minus 121. And then again, this should end up being a plus because it's a negative times a negative. And then if I do 4 times 4 times, if I do -4 times 4 times -20, that should be 320. And then 2 times 4 is 8. If I just keep on simplifying here, if I do 121 plus 320, that should be the square root of 441, I believe, divided by 8. And then if I find the square root of 441, I think that's going to be 14, but I'm going to double check it here in a calculator. Yep, that's going to be not 14, it's going to be 21. I was at least in the multiple range. And so then I would have -11 plus or minus, I can pull out that whole entire square root, 21 divided by 8. And then this is actually when you're going to get some whole numbers or some fractions, guys. You got to complete it all the way through. So then you guys are going to do -11 plus 21. So -11 plus 21 would be 10 over 8. And then if I simplify that, that would be 5 over 4. And then if I had -11 minus 21, that should be 32. -32, I should say, divided by 8, which is -4. So your two answers for number 4 would be 5/4 and -4. Again, if you are able to use Desmos to check your work, because a lot of the time little mistakes can be made. It happens to everybody, even the teachers. So you just got to make sure your work is accurate. All right, this time, guys, we have to work a little bit differently because our C is not with the x squared and the x. So what I'm going to do is I'm going to move this over just by adding it to both sides. And then this would equal 0. A key piece of the quadratic formula is that the original formula equals 0. Okay, so then I would have x squared minus 10x plus 25 equals 0. And then I can label my numbers. I can have A as 1, B as -10, and C as +25. And then again, I'm just going to plug it into the formula. And again, if I have a negative times a negative, this becomes +10 plus or minus the square root of B squared. So it'd be -10 squared minus 4 times A, which is 1, times C, which is 25, divided by 2 times 1. And I'm just going to extend my page here a little bit. And then I just keep simplifying. So I'm going to have 10 plus or minus the square root, and -10 squared is 100. And then it's going to be minus 4 times 25 is 100, divided by 2. And then I keep simplifying. 100 minus 100 is 0. And you guys are going to see here that in this case, we are only going to have one x-intercept because when I take the square root of 0, it's 0. So it's just 10 divided by 2, which is 5. So typically, guys, what that means is that we only have one x-intercept. It only crosses the x-axis once, but also it's what we call a double root because it is a perfect square trinomial. All right, one more to go, and then you guys can try some on your own. All right, last but not least, this one is in quadratic formula form, so I can just go ahead and do A as being 1, B as being 2, and C as being 4. And then I'm going to have -2 plus or minus the square root of b squared, which is 2, minus 4 times 1 times 4, all divided by 2 times 1. And I just keep going when I have -2 plus or minus. Now this time you guys are going to see a new pattern. 4, and then -4 times 4 is 16, divided by 2, because 2 times 1 is 2. 4 minus 16 is going to be -12 divided by 2. So we are going to have an imaginary root on this one. And so again, what you guys want to start thinking about is we're going to pull out that I, and we're also thinking about perfect squares that go into 12. I know 3 times 4 is 12, and 4 is a perfect square. So if I were to take the square root of that, it would be 2 root 3. And so then I would have -2 plus or minus 2i root 3 divided by 2. And because you have imaginary numbers, guys, we cannot do anything else with this radical. But you guys should notice here that we have 2, 2, and 2. We can simplify that. We can just divide everything by 2 to get -1 plus or minus I root 3. Now, in this case, guys, you wouldn't be able to check on Desmos because you have imaginary numbers, so it's not going to cross the x-axis. All right, but what you can do is just double check, plug it back into your formula, and make sure that it works. So hopefully this helps you guys kind of figure out how to use the quadratic formula. Please reach out to your teacher if you need more help. Otherwise, have a fabulous day.